All right. Hi, my name is Austin Cook, and I'm a product manager at Jabil, and I'm going to talk about our DC-MHS platform. Next slide. So Jabil has developed a DC-MHS platform that is compatible with multiple vendors and works with multiple generations of CPU. How we're able to do that is DC-MHS specifies the internal elements of a server, things like the motherboard or HPM or host processor module. DC-MHS specifies the keepouts, the board dimensions, connectors, connector locations, and pinouts, and that allows multiple vendors to develop independently from each other the elements that go inside the chassis. Now, the chassis itself is not part of the DC-MHS specifications. So it's up to the vendor to develop a 1U or 2U 19-inch rack system, a storage dense system, GPU, 21-inch, whatever it may be. So there's a lot of flexibility there as far as the solution that you provide to your customer while still adhering to the DC-MHS specifications. So we have actual proof points here in the Expo Center this year showing how DC-MHS allows us to collaborate with multiple vendors. AMI has one of our chassis up and running with their SCM module. We have another example of our chassis being used with multiple CPU vendors. And if you want to see us demo a upgrade from Intel, different Intel generations of compute HPMs, you can come over to the Experience Center and I could show you how we accomplish that. So again, this is all accomplished because DC-MHS specifies where those components go. It allows us to accommodate many different vendors' designs, and how we do that in our chassis is with minor modifications. We accomplish that compatibility with the 10 pin, changing the Z height of the standoffs, and then we also have just ever so slightly a little extra width to our rear I/O slots. So that allows for different board widths as going from generation to generation. We're expecting to see increased board layer count due to PCIe Gen 5 or Gen 6, increased memory lanes, right? So our design is already anticipating that we need to accommodate the additional board layer thickness. So we have a table up here giving you kind of an example of where those cutoffs are and where we need to make those design accommodations for different board thicknesses. So, next slide. All right, I'm going to hand it off.
Okay, thank you. Yeah, thank you very much. So, hi everyone. Thank you for being here. My name is Aurelio Rodriguez. I work for Intel, and I'm a power supply architect. And as part of the DC-MHS architecture, we also have internal redundant power supplies, which are hot swappable. And as we can see here in our 3D models, we have three main form factors. One is the 185 millimeters by 73.5 millimeters and 1U height. And we have the long form factor, which is 265 millimeters in length, same 73.5 millimeters in width, and same 1U, so the cross section is the same. But also, this comes from the legacy M-CRPS, and now we have a new form factor, which is the 60 millimeters in width, which today we have between 1.5 and 1.8 kilowatts. And the idea of this specification is to try to standardize the server internal redundant and hot swappable power supplies, so everybody can have the same specifications for all the platforms. We have been working together, Intel, Dell, AMD, HPE, and others in the work stream, so we can collaborate together and have the exact same specification for all their power supplies, which we think is going to make things easier. And as part of this effort, we also not only want to standardize the specification itself, but also the test setup, the test PCB that we all use to test the power supplies. And my colleague here, Richard Kauban, is going to present all the features that they have in the test setup from Artesim.
Thank you, Aurelio. So good morning, everyone. I'm Richard Kaubang from Advanced Energy. I am a product line manager. I'm in charge of the M-CRPS development within our company. Intel was gracious enough to also ask us to participate, and we are developing not just the power supplies, but what we think should be the industry standardized test board, which would take care of correlation issues between suppliers, between labs, our bench versus your bench thing. We're trying to minimize the variables, and we believe that having a standardized test board would really help everyone in, correlate test results. So the test boards that you see here will have one new single board test setup, and we also have a 1+1 board test setup. And it will support all kinds of configurability, monitor all signals available, the newer signals like DSSI, IMON. We have samples at the Experience Center, so just visit us at the Experience Center. And then we also have, Advanced Energy also have our own booth, and if you want to talk about the power supplies and test boards in detail, feel free to visit us at booth A7. Okay? Okay, and a new feature of the M-CRPS standard is the DSSI. This is an alternative communication bus to I2C, or the PM bus, right? Where everyone is aware of what PM bus is. Now, aside from PM bus, there's also this DSSI where the system will be able to communicate, configure the power supply characteristics. We also have a demo where we're demoing the DSSI communication in the Experience Center. We have power supplies there that's able to communicate with the system via DSSI. So feel free to visit the Experience Center as well. Okay. Thank you.
Thank you very much for being here, and please, again, go to the DC-MHS Experience Center to see systems from Jabil and also the DSSI demo and the M-CRPSs. Thank you.